So let's begin. We have grid questions G1, and let's begin here. The surface area of a cylinder. Okay, this is simple stuff. First, they gave us the surface area in terms of R, but there's one missing value here. First, we'll get H in terms of R. So they gave us the volume and they gave us the formula of volume. So we do pi r squared. H is equal to 3, 4, 5, 6 pi. Cancel the pi, and then you get H is equal to 3, 4, 5, 6 over r squared. Now that you have H over here, what you do is you plug in this H value into this formula right here. We just plug it in here. So we just get all R. Okay, so we just plug in H, and then what we get is 2 pi r 3, 4, 5, 6 over r squared plus 2 pi r squared. We cancel r. You get 3, 4, 5, 6 times 2. What I get is 6912 over r pi plus 2 pi r squared, meaning that 6912 is equal to b. Over here, b is equal to 6912. What is the minimum surface area? We must find the derivative and second derivative. The first derivative is to get the stationary value, and the second derivative is to get the nature of the stationary value. So first we'll derive what we have here. We had initially s. We'll just write this as 6912 instead of b, and that means that ds over dr, or the derivative of surface area, is equal to minus 6912 over r squared pi plus 4 pi r, and we must set it equal to 0, and then I have to cancel the pi since it's equal to 0, so I can just divide both sides by pi, and then I can also multiply both sides by r squared, so I get minus 6912 r squared plus 4r cubed is equal to 0, and then I can just get 4r cubed is equal to 6912, and then to get r cubed I must divide 6912 over 4. I get r cubed is equal to 1728, and that means that the cube root of 1728 is 12. R is equal to 12. Now, is this a minimum? Let's find out. We'll get the second derivative. D squared s over dr squared is equal to, how do you get the second derivative? It's not that hard. We honestly don't. No, yeah, we just put it in the second derivative of this. Minus 6912 r minus 2 plus 4 pi r, and we derive it. We get 6912 times minus 2. I get 13826 r minus 3 plus 4 pi is equal to 0. No, I don't really have to put equal to 0. I have to put the r in here and determine if it's concaving up or concaving down. So I put it in here, 13826 multiplied by 12 power of minus 3 plus 4 pi. This here, it shows that when I do this, 13826 over 12 cubed plus 4 pi, it was greater than 0, meaning that it is concaving upward, which means that it's concaving upwards, meaning that r equals 12 is minimum, which means that we already proved our r equals 12 is our minimal, and they want us to include centimeters, so we put centimeters. Yeah. Wait, sorry, wrong question, to go all the way back up there. yeah, they still want r equals 12 centimeters. Here you go. So r equals 12 centimeters over here. Moving on, we have a square of sides x is removed from each corner, so we have square cardboard, and then we have from each corner is taken out small segment. In each one has side x. Okay, now what happens? Once these are cut, I have this kind of shape. Okay, and then I get the sides. With each side initially had 20 and 20, so now it has 20 minus 2x, 20 minus 2x, and x on each side. I flip from here and then I flip it upwards to get an open box. So x eventually becomes the height. X becomes height of the open box. So now I get this diagram here. Okay, now I get this with height x and bases of 20 minus 2x. So, and to get the volume, it is equal to 20 minus 2x squared multiplied by x. So now that I got the volume, and now they want to find the maximum. To find the maximum, we must derive dv over dx. It is equal to, and we have to do the product rule mixed with the chain rule. So here we'll say u is equal to 20 minus 2x squared. U prime is equal to 20 minus 2x multiplied by minus 2. Again, u prime is equal to minus 420 minus 2x. And then v is equal to x, and v prime is equal to 1. So now I just do u prime v. U prime is minus 420 minus 2x. U prime v plus, wait, let me just move everything aside. Oops, sorry. I moved everything to the other side here. And then I get v prime u. U is equal to, again, 20 minus 2x squared. And then over, no, actually no need for over, that's it. And then we just have to simplify the derivative. So what we get is, we have to look for common terms here. Common terms is 20 minus 2x. So we have now minus 4 minus 3 plus 20 minus 2x. I forgot to multiply these two. Once you multiply these two, you get minus 4x. And then you, with the like term, you get 20 minus 2x with that. And then you get 20 minus 6x, 20 minus 2x. Okay, now with this, what you can do is you can draw the table of variations, which should not take so long. First I set it equal to 0. What are the possible values of x? Okay, so I drew the table of variations. First I got the x values over here, where they are all, oh wait, they didn't give me enough space. Over here, 20 minus 6x and 20 minus 2x. When it was y dv over dx, and they want to equal to 0, x was supposed to equal to 20 over 6, and x equal to 10. I put it in the table of variation over here, and then I figured out that x equals 10 over 3 is maximum. So k over here is equal to 10, because it was initially 10 over 3.